A lot of talk recently about aeroplanes and their fuel. Mostly it's the A380. I didn't really take too much notice of it till I started hearing about the weights. Let me just shut that window. When I started to hear the weights involved, particularly the fuel, that's what got my attention. In those wings alone, you're supposed to have 210 tons of fuel, right? Then you've got the actual engines as well. I think they're 4 ton, the engines. So you're looking at another 4, 8, 16 ton for the engines. Let's just stick with the fuel for now anyway. Let's not complicate things. 210 tons of fuel. Now I'm in a tower crane. Pretty big one. This crane can lift 8 ton. Average crane on sites in Britain is about 6 ton. You get obviously a lot heavier lifters and a few smaller ones like ped cranes. This machine can pick 8 ton up. So just to give you some idea, you need 26 of these tower cranes to pick up the amount of fuel that just goes into the wings. Think about that. 26 of these big tower cranes to pick up the fuel required, to lift the fuel required in the A380. That's not including engines, that's not including the weight of the plane, that's only included the fuel that goes in the wings. Yeah, 26 tower cranes. Let that sink in.
some little planes that go from the tiny airport just a few miles from me. Man, I can't hardly pick them up. Man, I can't hardly pick them up. They're going 3 to 4 times as fast as that other plane, huh? As that big jumbo jet. So how can the big jumbo jet stay in the sky going 50? These guys, these kind of planes only go 150, maybe 200. Look how slow he's going. I'm only zoomed in tenfold.
The fuel system, let's read what it says here. Widely accepted that an aircraft's fuel system has more profound effect on its performance than any other system. This one has 11 separate tanks, 21 pumps, 43 valves, one of the most advanced in the world. The size and scale of the A30, Here we go. Owing to the fact that it's fully loaded, there is some 118 tons of fuel being carried in each wing.
Korean Air. I'm only zoomed in 30-fold. Now I'll back it out because you gotta just see this is ground speed. This ground speed can't be more than 50-60 miles an hour. Look at that. Man, I can't hardly pick them up. They're going 3 to 4 times as fast as that other plane, huh? That's no zoom. That plane is right over our heads. Look at that.
Try to keep this balloon in sight as long as I can. With my eyes, it looks like, I don't know, a couple 100 feet in the air. You see the sun reflecting off it. Got it on the stopwatch, but you can see how the sun is screwing with the visual of the balloon, right? It's a bright blue sky day out today. I'm gonna try. I think we lost sight of it. Yeah, I can't see it with my eyes. It's gone. Again, I'll hang out here just in case it's visible on the P900. The P900 is fully zoomed and nothing there. Out of sight, out of mind. I zoom back in here. I'm going to zoom in a so-called plane chemtrailer. About as far away as that balloon, right? But yet I can get right up on this thing. In fact, I can't get that close because it's too close to me. So this thing's very small and not that far away. Hey, let me show you how far away this looks to the ground, on the ground. See that? But yet I can do this to it. I got one going overhead too, but we'll stick with this one. And that's not even full zoom. Alright, see, I went to 83 zoom and couldn't do it. And this is going to get closer too. Let's hang out a minute. Can't keep it in full focus. But there you go. These objects are a lot closer than we think. Because from the ground, look. Okay, so guys, I'm thinking that planes, when they fly in the sky, they're flying a lot slower than everybody knows.
This isn't going to be one of my typical build videos, so if you don't want to hear me talking, just lower the volume and watch as I assemble this 3D printed model of a gas turbine engine. Project peppered in here and there. As a thank you for hearing me out, I will now spin this 3D printed model of a gas turbine engine as fast as I can with compressed air.
Hello everyone, Dave here from Enslaved by No Media. So you think compressed air doesn't have a place in the world right now? These planes are not running on compressed air, you say? Well, if the entire world, the entire manufacturing world is running off of compressed air, and I'll get specific soon, I'm going to show you technology that is just going to blow your mind. And how can we as a people stand for this? How can we sit back and have to pay all our energy bills knowing that giant industry is paying nothing for theirs? They're charging us cost to market for everything that comes to market. They're charging us for the whole, transportation of everything around the globe, and their energy costs, which are practically nothing because they have compressed air, steam turbine compressed air, all kinds of different compressed air. I'm going to show you a video and you let me know if this looks like the jet engine and the technology that's being used in these A380s. And it's the same technology being used in giant manufacturing, power plants, all kinds of energy production throughout the entire world. All right, let's have a go.
Federal gentlemen, in this very moment. Ladies and gentlemen, in this very moment, I have both the honor and the pleasure to give you the AR Max 1 Uyangra 1.
public notice of nonprofit educational fair use in compliance with Title 17, Section 107 of the United States Copyright Code. Federal law allows citizens to...
So then we'll go on here. They're showing you there's various places where all the tanks are supposed to go in, but there's all these struts supporting the wing to give it strength, because obviously when you're flying supersonic, these wings are going to be subject to some immense strength, you know, forces and whatnot. But then also you've got to put room for the actual beautiful engines themselves underneath here. And anyway, I've done that page, sorry. And there's, what did it say here? Smoky Joe's, well, nitrogen oxide. Nitrogen, if you're separating the air, which I'm telling you these engines do, nitrogen oxide will cause this smoking effect. I do believe I read about that. Here's the, showing you the tiny, thin, look how thin those wings are, yeah? And there's the engine. You can crawl inside that bit, but that bit you're not going to crawl inside there. And what I'm saying to you, that picture was faked. More pictures. I mean, it's a marvel of engineering, an absolute marvel. Excuse me. And I can get there you are. Absolute. There's, you know, these are steps designed for a human to walk up, not a giant. And the steps have you can look them up. They're a certain size so you don't trip. And then look at the tiny little wings. There's no liquid fuel gone into any of this, is what I'm getting at. A large mass of air must be supplied to the turbine in order to produce the necessary power. The mass of air is supplied by the compressor, which draws the air into the engine and squeezes it to provide high pressure air to the turbine. Now, I'm just going to read this next bit, because this is the crux of it to me. Right, if the compressor and turbine were 100% efficient, the compressor would supply the air needed by the turbine. At the same time, the turbine would supply the necessary power to drive the compressor. In this case, a perpetual motion would exist. That's where it should end, because they have invented a perpetual motion free energy generator.
Remote control, electric motors, robotics, lasers, 120 years, 30, 40 years ago, folks. And look at this, limitless free energy. So what do you think the powers that be, the power and control, have had? They've had Nikola Tesla technology of free energy for over 120, 30 years. For those that think that we need fuel to run planes and stuff, that's ridiculous. It's absurd, but that's all they offer us, folks. So yes, it is valid to question the stuff, whether jet fuel is in planes or not and whatnot. So I want to just bring this to your attention and also introduce those that you don't know to Victor Schauberger, another one that gave us free energy. Here, take a look. The majority believes that everything hard to comprehend must be very profound. This is incorrect. What is hard to understand is what is immature, unclear, and often false. The highest wisdom is simple and passes through the brain directly into the heart. Victor Schauberger. He developed an aircraft engine that would work on the same principle as the Trout turbine by using air as the fuel source. It would suck in the air and convert it to fuel while flying, and at the same time create a vacuum from in front of itself, which would move continuously without resistance. Perpetual energy. The vortex, right? Free energy. Now think about the Big Bang Theory. When do you know when the explosions create things? No, explosions break things apart. What he put together was implosion to create energy like a tornado concentrating its energy.
Right, this is evidence on why jet engines do not hold any liquid fuel in the wings. If you notice here, okay, all of these access panels are open. These are a good idea for when things go wrong in the future. You can just remove them and get your hand in there and fish through wires and whatnot. But they do this stress test. Okay, I'll play a bit more.
We have in front of us more than 2,500 tons of steel.
No, you don't. It would never fly. It's made of aluminium and titanium. It's the most strongest light. Well, the titanium strongest, lightest weight material on Earth.
Right, this one is on flaps. This is the underneath of one of the wings. Just look at the amount of hydraulics going on here, and what we're trying to look for is fuel tanks. Can you see any? There isn't any. Here we go, it goes underneath here, and look at this, look at the thickness as well. Yeah, it is an engineering marvel. I'll turn the sound up if you want. It's quite annoying. Look, they are. All this is going on. All the electronics, hydraulics. There's more piping as well going from to the actual gas turbine engines. There's more of the piping inside here. I mean, look at this. Look at it. Look at the actual size of it as well here. Yeah. No room at the inn for those tons and tons of liquid fuel they keep telling us about. It's only a quick video, but I think it pictures speak 1,000 words. You don't need to be an engineer to realise the amount of stuff that's required. Yeah, this is heavy gear. This is proper stuff. Anyway, I'm gonna give full credit to this YouTuber here, Jagira 45. Boeing 737 flaps extension and retraction. Thank you very much for that. But here we are.
Now let's take a look at these. They're a bit loose. This is normal. This is the way they should be. Here we are outside with our cutaway. This is the exact same thing we were just looking at. This is an LM 1500 J79 rotor, and what's different about these blades jet engines use air as their fuel. Evidence. Tiny little wings. Tiny wings. This is the missiles. Then you have to have room for these to go inside. They fold up in there. This is the engine part that goes all the way to the back. And this is where your guy sits in it, yeah? There's no room for fuel tanks. Right. Another one. Skinny, tiny little wings. Air goes in, air is compressed down. It is ignited because air is a gas. You can ignite it when it's hot enough. It's combined and then it comes out the back and gives you propulsion. And inside here is showing you what are these missiles and stuff. And obviously you've got to have room for the landing gear in there somewhere as well. Right, again, skinny tiny little wings, and a lot of these wings on these planes fold up. There's a folding bit here where they lift up so they can go down into the aircraft carriers. Air intake, all the combustion and everything happens in both sides of these. No room for fuel tanks. No room for fuel tanks. That's just gas. The air that's been compressed gets really, really hot and is ignited. It comes out the back. The flames you see are no different to a flame you'd see on a gas hob. Beautiful. And here it is. This is an engine. But they never have any fuel dripping on the ground. They don't put down anything because there is no liquid fuel going into this engineering masterpiece. And here we have a Fibonacci spiral because it uses Fibonacci compression. And yes, it needs electrics. Yes, it needs oil inside this to keep the bearings lubricated like a fidget spinner. And there is no liquid fuel. This is how this thing sucks the air in, superheats it up to such a high temperature that it can be burnt, and out the other end comes the hot air going at such a velocity that it causes the thrust to push the thing forward. And there's your Fibonacci spiral. Anyway, of course the military are going to keep that secret, that knowledge, because, you know, they want to charge us for it. They want to tax the air we breathe. And the same engines are used in the production of electricity, and we're paying for air in that industry as well. You know, it's something to be proud of.
But basically, when you watch an aircraft come into land, when they're coming in with turbulence and whatever else, yeah, near enough, one of these struts can take the whole weight of the aircraft, because as it comes in, sometimes they come in at an angle and they bounce down on one of these sides, sometimes even just one of these tyres. But what we're looking at here is a pathetically lightweight tyre. Yes, it's big, but it doesn't weigh a lot. I mean, they're making out, look, I mean, it just rolls, piece of piss, absolute piece of piss. I no doubt he had to study for two years to get a degree in how to change a tyre. That's the way the world's gone nowadays. I'm not having a go at the guys doing the work. It's not what it's about. It's the whole bullshit lie of liquid fuel that it's all about. But I can't remember whether it was Goodyear, don't quote me on, or Michelin, one of these two. There was a plant over here that used to make the tyres for the aircraft, and I can't remember off the top of my head whether it was 40 psi, something like that. But it's not a massive amount of psi, and just look at these things. That's supposed to be a 6-ton engine there, adding on all the weight of this aircraft, all the weight of the passengers. It's just nonsense. It's just a joke, like everything else in this industry. It's just, the figures are just ridiculous. They just make them up. There's that back one with the starter car, and then there's all the...
Right, this channel, their copyright, How to Fuel an Airbus. Let's play.
How to fuel an Airbus. Here's the pit. It goes over that fuel farm right over yonder.
We've discussed those in a previous video that they're not liquid fuel. That's the same like gas tanks anyway, or air. This is the best video I've found on YouTube.
Put that into the pit, lock it into place. Make sure everything's secure, we're good to go. Let's go ahead and bond the aircraft. This is a bonding cable. This is a single point. Plug that into the wing. We open our fueling panel here. Open up the valves. We want to put fuel on the wings today. Getting arrival fuel on board. That way we know what we're going to put on board.
Right, here we go. This is pounds times 1,000, so we've 8.6, so we times that with 8,600. Let's put this into some sort of context for everybody. 8,600 pounds is 3,900 kilograms. 3,900 kilograms is 3.9 tons. And as I've discussed in previous video, that's actually half a ton of sand, which should have the same weight as liquid, unless for some miraculous reason liquid that goes into the aeroplane is a different kind of liquid to that we're used to. But anyway, then I'm just going to show you this one. 1 US gallon is 3.78 litres. Now you know what you buy litres of drink and things like that, so I'm just giving you that one before I go back to this. Let's go back to this. This is this is a great cracking video, but anyway.
And go ahead and fuel this thing.
Basically, when they've done, he presses a button, and then obviously this sends a message to the cockpit to say, yeah, fuel's been filled. It looks as tacky as that and as unprofessional as this. Anyway, I'll carry on.
Delta Airlines, flight 922 going to Salt Lake City.
Actually, this fella reminds me very.
This will initiate the fuel flow. We're going to pump about 400 gallons a minute.
We're going to pump about 400 gallons a minute. Okay, so we'll tap in 400 in here. Oops. So he's saying that this amazing pump can pump 1,514 litres of liquid fuel into the wings. Just want to put that into people's heads. I've covered that my hot water cylinder is 210 litres. Just Google literage. There's not even a sound comes off this thing when it's filling as well. Anyway, I'm just trying to give people, you know, why I'm telling you.
19. That's how the fuel and air
Yeah, simple as that, is it? You don't do anything, do you, buddy? And it's this to show you. This is gallons. Not making it up. Look at the speed of this goes. Boom, 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 boom. Before it ends. Right. Look, there it goes. Oh my word, that's quite impressive, isn't it? Video, it's about to end there. It's about to end and it's at 61 gallons, and you couldn't hear anything. You didn't hear a damn thing. So we would, you know, in a few seconds, he's telling me he's put 230 litres of fuel, liquid fuel, into the wings. Anyway, it's just me saying, if you can't grasp your head around that there is no liquid fuel going into these aircraft. They've made something that looks really impressive from a layman's point of view. You employ people, no disrespect to this guy, he's just doing a job, but they're taught to follow procedure, like he's saying here about the static. You know, if they thought there was any risk of, you know, flammability, he'd be wearing a flammable suit. And also when he pulls out the connection here, where it goes into the actual wing, there's no eye protection. He's just wearing a set of shades, you know, because there's never a drip or a drop. I mean, if you can't see this, it's just for show, just for show. Anyway, I'm going to leave it there with this one. I'm just keeping my hand in there just to tell you I've not forgotten about this one, and I will not let this one go. Thanks a lot.
This is your Fibonacci spiral I keep talking about, because this is how this engine works, by compressing air, just like a tornado does, and then burning it. And there it is there. It's absolutely, we should just be so
proud of this as a human race, of what we've achieved by inventing this engine. And here we go. This is the fuel filter he's checking. Now, when they say fuel, this, I'll show you in the next video what I mean. Here, this thing here, and then this thing. He's checking around it. Right, what? And that's all you're going to get, and there's all the hoses and stuff. But it's just a marvel, isn't it, eh? Absolutely marvellous.
Very closely as the fuel pump approaches the accessory gearbox. If it's not adjusted,
the fuel pump approaches the accessory gearbox. So this provides fuel for the accessories, and fuel being air, this could be the aircon for the air conditioning, etc. inside the cabin. And obviously if there's a pump here, it's going to need lubrication, it's going to need oil and a filter. So I'll just go back a little bit. I mean, they're all you aviation engineers are very thorough.
and now we'll raise the lift fixture up to the adapter on the fuel pump.
There you go, keep saying fuel pump. So all those laymen's are going, oh yes, obviously that's a giant fuel, fuel filter pump thing, isn't it?
That looks pretty good. Okay, with all of our mounting hardware removed, lift fixture connected, a little bit of a preload, fuel pump will slide right off the mounting studs.
Fuel pump, right? Pump the fuel. Giant, it's air, okay? For the ancillaries, accessories, and there's your air. Yeah.
With the fuel pump removed, remember that all.
And now he's just going to tell you all about the various O-rings and how to put them on properly.